Okay, this is the second page of the Algebra 1, Unit 4, Linear Equations and Inequalities Review. So I've rewritten some of these because it's hard to see and you could not really see the shading. So for Bundle 2, Number 2, Solutions of Linear Inequalities, which inequality can be represented by the graph below? So it's asking which of these equations does this graph represent? So basically you need to determine what the line would be and then choose the right equation. So the first thing I'm going to look at when I look at this is I notice that the graph is shaded above. Now on your copy it's hard to tell that, so it looks just like a plain line. However, it's shaded above, so I know that y is greater than. So right here, I'm going to come down and notice that number 4, y is less than, so I can immediately take that one out of the situation. These two are in standard form, so that means that in order for me to determine if those are possible solutions, I would have to change those into y-intercept form. So if I were to take number 2, x minus y greater than or equal to negative b, I would move my x to the other side. I would get negative y greater than or equal to negative x minus b. I'm going to divide by 1 to get that negative off of there. When I divide by a negative, I have to flip my sign. So I would get y now is less than or equal to positive x plus b. But now I know that y cannot be less than because the shading is above, so that takes number 2 out of the equation. Then if I were to take number 3, x plus y less than or equal to b, if I put this in slope-intercept form, y less than or equal to negative x plus b, y again is less than, so I automatically know that is that equation. But just to make sure, let me just look at y greater than or equal to x plus b. This is my y-intercept. I go up here, I look. B, in fact, 0, comma, b is my y-intercept. And my slope is positive. So I know that that is a positive slope. So I know that number 1 is in fact my answer. Moving on to number 2. Graph the inequality where x minus 4 is less than or equal to negative 2 times y plus 6. So again, I'm going to have to put this in a form where I can reasonably determine what the y-intercept, the slope, and the shading should look like. So I'd like to put it into y-intercept or slope-intercept form. So I take, which essentially means I'm going to take this equation and solve for y, because slope-intercept form looks like y equals mx plus b. It essentially is telling me to solve the equation for y equals. So, essentially getting y on one side and the rest of the information on the other. So in order to do that, the first thing I'm going to do is distribute my negative 2. So I'm going to leave this the same it is for right now, negative 2y minus 12. Then I'm going to leave my y on this side, and I'm going to move my 12 to the other side. And I get x plus 8 less than or equal to negative 2y. Then I need to divide by negative 2 because I want to get this y by itself. So I'm going to divide by negative 2, and when I divide by negative 2, I need to flip my sign. So I get negative 1/2 x minus 4. Oops, I forgot to flip that sign, greater than or equal to y. So this is the equation represented in slope-intercept form of this. So then I'm going to go look here, and I notice that basically all of the lines have a y-intercept of -4. This is my B. They also all have a slope of -1/2, moving up 1 and to the left 2, or down 1 and to the right 2. So every line has a -1/2 slope. So neither one of those help me. What is going to help me is I know that y is less than or equal to the line. So I'm going to look. This is greater than, so I know that is not it. This is a less than, so that could be it. This is a greater than, so I know that's not it. It's greater than because it's shaded above. This is a less than because it's shaded below, so that could be it. The only difference between these two is one is a solid line, one is a dashed or dotted line. So I'm going to look. It is greater than or less than or equal to. So I know that since it's equal to, the solid line is what I want. So C is my answer. Moving on. Determine the linear inequality associated with the given solution. So first find the equation of the line, then rewrite the equation as an inequality using the symbols. So the first thing I'm going to do, I use y equals mx plus b. I know I'm going to have y equals, and it is, my y-intercept is going to be positive 1, 2, 3. My slope, this is at 3 as well. So if I go up 3, and to the left 3, my slope is going to be -3/3, which is 1, which is basically y equals -x plus 3. Now, one thing that did not show up was this portion was shaded. So since the lower portion is shaded, my inequality is going to read y is less than, because y is getting less than -x plus 3. However, I also notice this is a solid line. So since it is a solid line and not a dashed line, I need to add the line underneath that. So here is my answer. All right, number 4. The scholarship is having an event at Rangers baseball game. Adult tickets are $8. Student tickets are $6. The Scholarship Association wants to spend no more than $96 on tickets. Here we actually have a graph where they have provided student tickets on the x-axis and adult tickets on the y-axis. So we know that adult tickets are going to be our y, student tickets are going to be our x. We're asked to write an inequality represent the number of adult tickets, which we know are our y, and student tickets, which are our x, that the Scholarship Association can buy for the game. So be conscientious about that. If they provide you with a graph that's already labeled, make sure you do that accordingly. So the adult tickets are, or the student tickets are $6, so 6x plus. Adult tickets are $8, so 8y, and we know that cannot be more than $96. So we know that 96 is the very maximum. So any amount of the tickets has to be less than $96. It can be equal to, but not more than. All right, so it says graph the inequality on the given coordinate plane. So I need to move this into slope-intercept form. In order to do that, I'm going to take 6x plus 8y less than or equal to 96. And I'm going to solve for y. I'm going to get y on one side of the equation because I want it in y is less than or equal to mx plus b form. So I'm going to take 6x, subtract 6x from both sides, 8y less than or equal to negative 6x plus 96. I cannot add these together because one has an x value and one doesn't. I'm going to divide by 8, and I get y is less than or equal to negative 6 divided by 8x plus, and x stays in the numerator, 96 divided by 8, which is 12. Now I can reduce that fraction to negative 3 over 4, because I know 2 goes into 6 3 times, 2 goes into 8 4 times. So in order to graph this equation, I'm going to go up to my y-intercept, which is 12, 2, 4, 6, 8, 10, 12. They're giving me the graph, but they're also indicating the units. So I need to go by those units. So I go up to 12. I also notice that these are 2 units apart. So when I do my slope, I need to be conscientious of counting appropriately. So when I go down negative 3, I actually go down, that's 2, so halfway in between is going to be an additional 1. So that's 3 halfway in between. Then I go over 2, 4. Then I'm going to go down 3, which is here, and then over 2, because that's 4 units. I have to make sure I use my slope in accordance with the units here. So I'm going to go down, that's 2, halfway in between is 3, 2, 4. And down 3 and over there. So when I graph my line, that indicates where the most I can spend on tickets and stay within the $96. But now I need to shade. Y needs to be less than, so I would shade this portion underneath. If I did not add the equal to, then I would instead have a dashed line. Pretend that that is right there on that line. It would be a dashed line instead of a solid line. If it was just y is less than negative 3 for x plus 12. That's what that would look like. All right, so I've written an inequality, I've graphed it. What is the maximum number of adult tickets that can be purchased? Well, here are my adult tickets. The maximum number would be 12. That is, what point on the graph does this represent? It is the y-intercept. When x is 0, y is 12. What is the maximum number of student tickets that can be purchased? My student tickets would be down here, the maximum number I'm reading, and it goes across 2, 4, 6, 8, 10, 12, 14, 16. The maximum number is 16, and that is my x-intercept. We haven't talked a lot about that, but it is where the graph is going to cross the x-axis. That is basically what happens when y is 0. X is 16. Okay? So if the scholarship gets an order for 12 student tickets and 10 adult tickets, can the Scholarship Association afford this many tickets? Well, how would we do that? We'll plug in this for our y, this for our x, and see if it comes out in the inequality. So if I take 6 times my x value, which would be the student tickets are x, adult tickets are y, so 6 times 12 plus 8 times 10, is that going to be less than 96? 6 times 12 is 72, plus 8 times 10 is 80. Is that going to be less than 96?